Okay guys, today we're going to go over how to calculate parts per million. And just bear with me because I'm using a new drawing tool here that I have at home, not the one at school. So parts per million, you're going to be able to find that formula on your table T. So let's see, how do I scroll with this mouse? There we go. Well, I'm scrolling the wrong way. So let's go to table T. All right, that's better. And underneath where it says concentration, which is right here, okay, there's two formulas. We've just done molarity for a whole week. That's this formula right here. The parts per million formula is equal to the mass of the solute divided by the mass of the solution times 1 million. So I'm going to come over here and I'm going to write that formula down. We're going to abbreviate it a little bit because that's a lot to write every single time. And rule number 1 is we always want to write our formula down. I hate that this mouse has a circle around it, so let's get rid of that. No. Okay, here we go. Parts per million equals, that's ppm, mass of the solute, so I'm going to go grams of solute, because grams is mass, over grams of solution times 1 million. And 1 million has 6 zeros in it. Okay, and let's go over a couple things. The solute is the substance that is being dissolved. If you don't know that, write it down. The solvent is the substance that is doing the dissolving. A lot of times that solvent is water, okay? And the solution is equal to the solute and the solvent combined. Solute plus, it's a plus sign, solvent. So if I have a beaker here, and in the beaker I have 10 grams of sodium chloride, and I have 100 grams of water. The solute weighs 10 grams. The solvent weighs 100 grams. And the solution weighs 110 grams. Because the solution is equal to the solute plus the solvent. So if you look up here at this formula, the grams of solute, which would be 10, over the grams of solution would be 110. Okay, so now let's go try a problem and see if we can make this work. These questions, these parts per million questions, these are great because whenever a Regents exam gives you a question that talks about parts per million, they will always mention the words parts per million in the question. So if you read this question, I'll just read it real quick. 25 grams of a chemical, doesn't matter what the chemical is dissolved in 75 grams of water. What is the concentration of the chemical in parts per million? So now, all of a sudden, you know that we need our parts per million formula. Grams of solute over grams of solute. Uh-oh, I hit the wrong button here. Hang on. Grams of solution times a million. Million has 6 zeros. 1, 2, 3, 4, 5, 6. Okay. 25 grams. Let's do green. 25 grams of a chemical is dissolved. This is the thing that's being dissolved. So this is the solute in 75 grams of water. That's the solvent. 75 grams of water. what does the solution weigh? The solution is solute plus solvent. So the solute was, oops, I'm doing the last problem, 25 grams, and the solvent is 75 grams. So the solution weighs 100 grams. That's the grams of solution. Okay, now we have our numbers. Grams of solute, which we said was the 25. The grams of solution is 100 times a million. So when we're going to put that in our calculators, we're going to go 25 divided by 100 times a million, and we're going to end up with come back here. Okay, we're going to end up with 250,000 parts per million. That's going to be our answer. Okay, now you try one. Number 2. Suppose we have 17 grams of sucrose is dissolved in 83 grams of water. What is the concentration of sucrose in ppm? As soon as I see ppm, I'm going to write my formula. ppm equals grams of solute over grams of solution times a million. Okay, let's examine. 17 grams of sucrose. That's the solute. In 83 grams of water. That's the solvent. What is the concentration? Okay, well, the solution is going to equal 17 plus 83. 7 and 3 is 10. 8, 9, 10. 100 grams of solution. Okay, so the grams of solute was 17 grams. The grams of solution was 100 grams. Multiply that by a million, and you will get 170,000 parts per million. Okay, that's number 2. Let's try number 3. 35 grams of ethanol, that's my solute, in 115 grams of water, that's my solvent. What is the concentration of ethanol in parts per million? So again, they gave us parts per million here, so we know that's the formula we use. Grams of solute over grams of solution. I'm going to abbreviate solution now, SOLN, solution, times 1 million. Okay, we have 35 grams of solute. Let's see, we have 115 plus 35, 150 grams of solution. I added these two numbers up, times a million. Make sure you have 6 zeros on your calculator. And I totally didn't. So let's do that again. And we're going to end up with 233,333.333 parts per million. Okay, now I wouldn't necessarily put this 0.333 in there, but if you put it into your calculator and you get that, that's absolutely fine. All right, number 4. The solubility of sodium chloride is 284 grams per 100 grams of water. Oh, Nelly. I didn't mean to cross that out. What is its concentration in parts per million? Parts per million equals grams of solute over grams of solution times a million. Okay, how many grams of solute do I have? 284. So 284 goes here. 100 grams of water. So what is the mass of my solution? 384. Why do you say that? Because you have 284 grams of solute in 100 grams of water, per 100 grams of water. So the solution is always equal to your solute plus your solvent. So that's going to equal my parts per million. It's going to be a big number. Okay, so 284 divided by 384 times a million. And we end up with 739,583. And then there's 0.333 at the end, but I'm going to leave that off. Okay, hopefully you're doing this along with me. All right, helium gas. 2.5 times 10 to the negative 4 grams is dissolved in 200 grams of water. Okay, this number, if I put it into regular notation, everyday notation, that negative 4 means the decimal is going to move 4 places to the left. 1, 2, 3, 4. Put the 5 on there. So now I move 4 places to the left. Grams of helium gas. So that's my solute. In 200 grams of water. That's my solvent. Okay, so here's my solute, here's my solvent. What is it in parts per million? So let's put our formula down. Grams of solute over grams of solution times a million. I have 0.00025 grams of solute over 200.00025 grams of solution. Remember, the solute plus the solvent equals the solution times a million. Okay, that's a little bit messier, but we're going to calculate that. So 0.00025 divided by 200.0025, and multiply that by a million. Make sure you have 6 zeros, and you get 1.25 parts per million. Okay, now this one we have to read very, very carefully. This number 6. Okay, it says 350 grams of a sample of drinking water. So the whole sample weighs 350 grams, and it has 41.2 milligrams of lead. 41.2 milligrams of lead, that's the solute. What is this? Is it the solvent or is it the solution? It's the solution. It doesn't say water. This is a solution. It's drinking water. It has the lead already dissolved in it, and it weighs 350 grams. So now, because the question asks for parts per million, we're going to do grams of solute over grams of solution times a million. When we put these in, we're going to end up with 41.2 grams of solute over 350 grams of solution. This is the solution. It is not the solvent. Times 1 million. Okay, let's do it. 41.2 divided by 350 times a million. And I get 117,714 parts per million. Okay? All right, go ahead and try some of these problems on this Edpuzzle. If you have to go back and watch parts of this again, go ahead and do that and let me know.